let's have a look at how we can use our calculator to find the boundaries for our confidence intervals. Um, please keep in mind, this is how you should be doing it. Don't use the formula, don't substitute all the values in and try and type all that out. Pretty much any time a student makes a mistake in finding a confidence interval, it's because they make an arithmetic error, because there's obviously a lot of numbers in your confidence intervals. Use your calculator, even if you're asked to fill in some gaps to show you know what the formula is and how it's all putting together. Still use this stuff here on your calculator in order to work that out. We're going to have a look at example 9. This is from page 277 in your textbook. This gives me another opportunity. I'm getting fewer and fewer of these opportunities as the year goes on, but one more opportunity to throw some shade at the textbook. They do talk about when we're rejecting the claim or not. This is based on a point value for the mean. Typically, you're going to get an interval for the mean. And in that case, look, we've got a much more sophisticated way of doing this. So refer back to that previous video. That gives you all the information that you need. So let's have a look at the example here. We've got some milk being dispensed into cartons. It's normally distributed. We've got a mean, which we can adjust, and we've got a standard deviation, which is somehow fixed. The value of the mean should be 1005 milliliters. Quality controller comes along, test 25. The mean of those 25 is 1002. Let's construct a 95% confidence interval. So on our calculator, we're in stats. We're going into interval here. It kind of looks like interval there. We've been working with the standard normal distribution here. So we're going to use the Z distribution for this. And here we get 4 options, 1 and 2 sample and 1 and 2 prop. We are going to use 2 of these options this year, 1 prop when we get to confidence intervals for a proportion, which we'll get to a little bit later on. 1 sample is what we're looking at today. If you look at those 2 options, 1 prop, we don't see anything about means and standard deviations here. That's a real giveaway that we're in the wrong spot. Here in 1 sample, we're looking for, we're given a standard deviation, a sample mean, and a sample size. Now, just keep in mind as well, if you go into the 2 sample as well, you can still go like 2 standard deviations and a sample mean and you're asked for 2 of everything, which you won't have. So we're going 1 sample here. We've taken 1 sample. We're testing whether the population mean is within that sample or not. So first thing we do, we've got our confidence level. We are asked to construct a 95% confidence interval. So we put 95% in there. If you just type in 95, by the way, it goes, oh, you want a 95% confidence interval. So it's kind of smart about that. We put the standard deviation of 10 in. We put our sample mean, which is 1002, and our sample size is 25. Notice how I'm not putting the test value in there. We don't put the test value in to the calculator to do anything with. We use this to come up with our confidence interval. We work that out, pressing execute, that our confidence interval is telling us the true population mean is between 998 milliliters and 1000 and, well, I guess 6 milliliters. And that's it, right? So then we're going to write exactly this, right? You want like mu in the middle because it's about the population mean. We're saying the population mean is between 998.1 and 1005.9. And look, just to talk about the claim here, if we're assessing this claim that the volume is 1005 milliliters, right? The value is supposed to be 1005. Is it 1005? Well, we can't say that it's not. We also can't really say that it is. All we're saying is it's between 998 and 1005.9. 1005 is within that range, but so is 1002. So is 1001. So is 999. And there's a lot of values between 998 and 1006. Okay, even decimal values. So we can't say that it isn't. We can't reject this claim. Can we support this claim? No, not really. We actually can't make a conclusion here. If, however, the value was supposed to be 1006, Well, 1006 is not within our confidence interval, so we can reject that claim at 95% confidence.